Hello, today I'm demoing my Federated Learning module over 3 MacBooks, so 3 learners, and also open sourcing it so the community can learn. Initially, I wanted to build distributed learning infra for a cluster of Macs, but the setup that I have right now works better for federated learning. So let's jump right into the demo. First, I'm going to show you the model.py here. There's 4 important variables we need: the device, the model itself. So here's my ResNet definition, but the model comes here. Then the criterion and the optimizer function. This gets synced to the learners, so the learners will have access to the same file. Then we're going to look at the utils.py, and this just defines a data loader. All this does is it gives me either a validation dataset, testing dataset, or a training dataset. I recommend you look into this part of my code later. So first, I will start my leader. Take note of the number of learners. I have 3 Macs set up here, and so I will wait for 3 learners to join. I'm going to start my leader with the learner count S3. And it shows that the leader started on this address. Next, I'm going to start my learner on this node as well. I'm going to start that, and you see a change here. It's currently downloading the data. It's also going to transfer a file to another folder called learner model artifacts, and the learner started on this port. So now I'm going to start the second learner, and with the same address that I gave there. I'm going to start that, and you see that instantly the models have been sent and they have been synced. Now let me start the third learner. I'm going to bring it here, start it, and you see here that the model has been sent again. And now the training is started. So you look at these 2 ones, they're still getting the data batches, and that's because the network costs are high. When it's on the same computer, the data batches get sent instantaneously, but on these ones, they take a little bit more time. They got their data batch, they're training right now. Leader accumulates all these gradients and sends that back. This is the training loop. Once this is done, Leader's gonna download something called a model.path file, which then you can use to basically store the model. So without training, with random weights, this model has an accuracy of 14%, but after training with this setup, you can see that we have 25% accuracy. So this works, right? I don't think so. The amount of time it took to train this model was 5 times longer than what it took on a single node on my Jupyter notebook. The reason why distributed training works on GPUs or a multi-GPU setup is because the network we use is a very high bandwidth network. Network costs are almost 0. I'm using Wi-Fi network, thus this repo can be used better for federated learning. Drop your questions in the comments. Thank you. Ping